Okay, so this is the last video for Unit 4. So the last video for linear momentum and system of particles. So what we're going to look at is what is known as a ballistic pendulum. All right, so a ballistic pendulum is a device used for measuring a bullet's momentum from which it is possible to calculate the velocity and kinetic energy. So ballistic pendulums are used a lot in the study of forensics and so forth, if they want to try to find muzzle velocity and things like that. So a way to think of the device is that it combines conservation laws that we have studied, and I forgot the word that. Okay, and so remember the conservation laws that we have studied. We studied conservation of momentum, which is what we're talking about now. And in Unit 3, we talked about conservation of energy. Okay, and so the ballistic pendulum uses both of these principles, and really it's broken down into 3 phases. The first phase is going to be the launch. Okay, it could come from a spring-loaded, weapon or something like that, and so generally here we will look at conservation of energy. And then there will be a collision of the projectile and whatever is making up the ballistic pendulum, which means here we're going to focus on conservation of momentum. And then finally, you're going to have the swing, right? It's called a pendulum because it's going to want to swing. And so here we will use conservation of energy. And so if the problem involves each one, these 3 phases, now you have the technique that you're going to use. And so if we look at this example here, and oftentimes one object will be given to you in kilograms, the other object will be given to you in grams, right? So here you have a 30-gram ball is launched into a 0.5 kilogram wood block supported by a light vertical string. The ball passes through the wood block and leaves with a velocity of 15 meters per second. The block rises to a height of 8.5 centimeters. A, calculate the initial velocity of the wood block during the swing, and then calculate the initial velocity of the ball when it is launched. Okay, and so if we just want to kind of do a before and after picture, so before we have, I drew that kind of small. Let me draw that bigger. Okay, and so here's my ball heading towards my block. Okay, so that's before. So if you want to say all the momentum is here with the ball, there's none with the block. And then afterwards, okay, we're going to have the block is going to swing, and then the ball is going to be traveling at a velocity of 15 meters per second. Okay, I know that looks like 18, but I assure you it is 15 meters per second. Right, and we want to know, right, how fast was the block moving here, right? And then we want to know what was the initial velocity of the ball. Okay. So what we're going to do is, right, we're going to look at for part A, we're going to look at the swing, which means we're going to look at the energy, and then the other part for part B, this area, we're going to look at the launch, which in actually not the launch, sorry, we're going to look at the collision, right, which means we're going to use momentum. All right, so let's get to work on solving this question. So part A, right, And so we're going to use conservation of energy, so E before equals E after. And the way it boils down to is that if we're looking for the initial velocity of the wood block during the swing, that means I'm going to have a kinetic energy before, right? And then once it swings to its maximum height, I'm going to have a potential energy after. And so I'm going to have 1/2 mv squared equals mgh, right? And so this is our very typical solving for any velocity, right? It's going to be the square root of 2gh. And so I'm going to say 2 times 10. I'll just use 10 for simplicity. You do have to be careful because it tells me that it goes to a height of 8.5 centimeters. So I need to make sure I convert that to meters by dividing by 100. So I'm going to move the decimal point 2 to the left. Okay, and so then I'm going to do 2 times 10 times 0.085 equals, and then I'm going to take the square root of that, and I'm going to get a velocity of 1.30 meters per second, right? So it's going to be the velocity of the block, okay? All right, so that side's pretty easy, right? If you can break it down by the three areas, right? Is it the launch? Is it the collision? Is it the swing? Then you can kind of determine which conservation law you're going to use. So part B, we're going to focus on the collision. And so that means we're going to use conservation of momentum. And so I set up my P before equals P after, right? Or P initial equals P final, whatever you want to call it, because here you have like block and ball, and it's just subscripts can get crazy. So I'll call the ball 1, the block 2, right? So I don't have to use like B and B, right? And so before the collision, only the ball is moving. So M1, V1 initial, right? And then afterwards, both of them are moving. So M1, V1 final plus M2, V2 final. But sometimes you guys may say, hey, but wait, we don't know the final velocity of the block after the collision. We actually do, because it's the initial velocity of the swing. So that VBF is our V2F, right? So it's our V2F for the swing, or for the collision, right? And so now I'm going to go through. I'm going to solve the equation for V1I, and so that's just going to be V1I equals M1 V1F plus M2 V2F divided by M1. And so that's going to be, again, now, so they give you the ball in grams, so you have to convert that. So it's going to be 0.030 kilograms times 15, because that's our after, plus the block, so 0.50 times 1.30 divided by 0.030, right? And so now I'm going to grab my phone to do my calculator. Again, I apologize for leaving my calculator at school. Plus, so I got 0.030 times 15 plus 0.5 times 1.30. So top is 1.1, and I'm going to divide that 0.030. So 1.1 divided by 0.030, and I'm going to end up with an initial velocity for the ball of 36.67 meters per second. So the velocity of the ball before the collision is 36.67 meters per second. Okay, and so that, again, ballistic pendulums is something that's going to be a little bit new concept in Physics C. It's not necessarily studied in Physics 1. And so that concludes Unit 4, right? Systems of Particles and Linear Momentum. All right, so now you should be prepared for the Unit 4 portion of the AP Physics C exam.